Let's look at some of the key parts of the implementation of typed class-oriented curly. We need to represent class declarations, and as usual we're going to do that with tuples that pair a class name with the content of the class declaration. So class T corresponds to that content, and that content includes a supername, a list of fields, and a list of methods, just as it did before we added types. The difference here now is that it's not just field names, but field names paired with a type for each field. Similarly, in our methods list, where we pair a method name with a method, that method has not just a body expression, but it has an argument type and a result type. So we're going to have a method T to combine that body expression with those two types. For the expressions themselves, we don't write any types in any of our expressions, so we can just reuse the XI data type that we had for the untyped version of our class-oriented language. A type in this world is either number or a class name, but we can't just say number or symbol here. We have to give it a constructor, so we're going to say obj of some symbol as a class name. That will be the type of an object, and specifically an object that instantiates the class that we put here as the symbol. Our type check function works on the whole program, that is, the main expression and the set of class declarations. Our main program, it's an expression, and again, it doesn't mention any types directly, so we can use XBY, again, to represent those expressions, while the classes all have type annotations on them. To type check the whole program, then what we do is we first type check all the individual class declarations, and then, assuming those are okay, then we can type check the main expression. When we type check an expression, we're using Typechecking. It needs the list of classes, all those class declarations, so that when we have a new or a send, we can check what the relevant class has. It also has a type for this and a type for arg. Just like our interpreter needs a this val and an arg val, our type checker needs a this type and an arg type. And since the main expression we normally provide a dummy object and just 0, we'll use obj object and numt as the arguments for those types. Typecheck class, let's look at that one first. So given the class name, the class declaration, and all of the declarations so that we can look up other classes, then we get the pieces out. It's got a superclass name, it's got a list of field declarations, and it's got a list of methods. So the fields, there's nothing really to check there. We could double check that all the types make sense, but we'll assume that you've written down a type that makes sense, otherwise it can't be used. The methods, though, they have expressions that we need to check and make sure that the method expression is consistent with the declaration. So that's why we have type check method here, which takes the method declaration, dropping the method name part off, and then it takes a class for this, and this is always the class in which the method is declared. So that's why we make an obj here using the class name. That is the class that we're currently checking. And then we pass along the list of all classes in case type checking needs to look at some of the other classes. In addition, though, to checking that the individual expressions in the methods are okay, we also need to make sure that any overriding that's in this class declaration is consistent with what's in the superclass. So we'll have another helper function, check override, to do that. And then all we have to do is apply each of these things to all of the methods that are within our class. And if that's okay, then that means the whole class is okay. To check a method, we've got the method declaration, we've got the type for this expression, that is, the class in which this method is declared, and a list of all classes as usual in case we need to look them up. Our type check method doesn't return anything in particular. If the method is okay, then we return nothing. If it's not okay, then we raise an error with type error. So for a method declaration with a declared argument type and a declared result type, then we've got a body expression. And what do we do with an expression? We type check it using Typechecking. On that body expression, and as usual the list of classes, the this type we pass along because that's the type for this if it appears anywhere in body, and arg type. We use the declared arg type in case anywhere in this body expression arg is used. When we do that, we get a result for the body expression. And we need to make sure that's consistent with result type. Making sure it's consistent is not the same as making sure it's exactly equal. Otherwise we would use equal here. But instead we use an is subtype function that checks whether whatever the type this is consistent as far as subtyping is concerned with the result type. and that is subtype test, may need to look at subtypes and supertypes in the sense of classes extending other classes, so that's why we have to pass along the class declarations. As long as the subtype test passes, then everything's okay, and we return nothing. Otherwise, we report a type error about this body not matching its expected result type. Our other helper function was check override. So here we're making sure that this method name is consistent with the declaration in any superclass. So we take the class where things are declared and get the superclass name. And then we have another helper function, find method in tree, that takes a method name, a class name, and all the class declarations. And it finds this method declared in this superclass, or in this superclass's extended class, or in the class that one extends, and so on. So that's why we need this generalized find method in tree. We'll need the same thing for fields as well. If that method doesn't exist, then instead of erroring, we can just use the current method and say, pretend that the superclass method had the same method as this. In other words, we want the test to always pass if we're not actually overriding, and so here's the simple way of doing that is just saying that we'll use the same method and then everything will match. If we do find a method in the superclass though, then that will be supermethod, and so we want to check that supermethod's argument type is the same as the overriding method's argument type, and supermethod's result type is the same as the overriding method's result type. If those match, then good. Otherwise, we need to raise a type error.